So I'm okay. I'll start now. Hi. So I'm Rohan. I'll be taking the session today uh, on introduction to Olympiad geometry. I am currently a third year, final year undergrad at Chennai Mathematical Institute in India. Uh, yeah, I used to do Olympiads. I was on the IMA team. I'm still involved in the training of the team and yeah, various parts of the Olympiad process in India. Uh, yeah, that's mostly about me. So today my goal is to just like cover some very basic Olympiad geometry. My plan is not to be very ambitious. Like I have a bunch of things listed, but we don't need to cover most of them. Uh, right. The other thing is, please feel free to stop me at any point. Just unmute yourself and speak up. If you put questions in the chat, I'll try to check the chat, but I'm probably not going to be that frequent with it. I would love it if you could have some of your videos on. It's very nice that way, and that would be helpful. It's nice. Uh, yeah, feel free to unmute yourself, ask any questions, and yeah, it's all good. Yeah, I let's start. Is that good? Okay. So this is roughly the plan for today. So what do we start? We'll because I want to introduce geometry. The goal is to the attempt is to not assume too much and try to build as much as we can and develop as much intuition as we can on how to think about these problems in geometry. So we'll assume very basic things. We'll assume congruency. We'll assume similarity. We'll assume like how parallelograms work, like the diagonals bisect each other and things like that. And these things we will not do, but uh, yeah, we'll try to prove almost anything else that we use. Does that make sense? So, okay, the rough plan is we'll prove the basic triangle centers exist, learn some techniques there, see like, how to think about them. Then we'll quickly just prove some angle chasing results on circles because we want to use them. I assume most of you would have seen these proofs anyway in school or someplace, but it will just quickly cover them in the first few minutes, just so that everyone is on the same page. Then third, we'll use our angle chasing and our newly developed intuition to prove something called the Simpson line. And after that, the last two things are kind of up in the air, depending on how much time we have. Like how much time we will split and put on these things, we'll see based on what time is left. Because I don't want to exhaust you all, because like long sessions can be fairly exhausting. So the idea is we'll look at some basic length chases and just seeing how some lengths can be computed with using the in-circle and the in-touch points. Again, that is something that most of you would be familiar with, but again, it would just be good to look at how to prove these things. And the final thing, which is the most exciting part, if we can get to it, is we'll look at plane transforms and how to think of things happening on the plane. So this could be rotation or homothety, whatever that, or dilation, and these kinds of things, and see how we can think of them. And maybe we'll look at a few problems. If we get here, that might be fun and interesting to you all. But let's see if we can do it. Bonus points if somebody can guess what the surprise problem is. Okay. Is this good? Any questions? You can also just unmute yourself and say no, even that works.
No question, at least from me.
No questions.
Okay, awesome. All right. So the basic four triangle centers that we care about: the incenter, the circumcenter, the centroid, and the orthocenter. Okay. So we'll prove that these four things are some. Like I'll define them and we'll prove that they exist. Okay. So we'll begin with the circumcenter. So what is the circumcenter? The circumcenter is we have this triangle ABC. So we claim that there is always a circle that passes through all these points, A, B, and C, and that circle will have a center. So there is a point O such that OA is equal to OB is equal to OC. Okay. So what is it that we want to do? OA is equal to OB is equal to OC. This is what we want to do. So how? So another characterization is, when is OA equal to OB? Like, what are the points on which OA is equal to OB? This is precisely the perpendicular bisector of AB, right? XA equal XB if and only if X is on perpendicular bisector of AB. Yes? Does that make sense?
Yes.
What is the point X here, if you can tell?
For any X, if XA is equal to XB, then X is on the perpendicular bisector. And if
Okay.
some X is on the perpendicular bisector, then XA equal to XB.
Okay, got it.
So this is kind of saying, let's prove that perpendicular bisectors of AB, BC, CA concurrent. Yes. So this is the problem we have. And okay, this one I'll just state a proof, and from the next one I'll ask you to give ideas as well, because I don't want to spend too much time. So why this might be tricky is because we have three concurrents, three things to do, and on like three conditions, right? Kind of. In some sense, there are three conditions. But the freedom of a point is in some sense like two lines we can make meet usually. So it's supposed to come from two conditions. So if we are able to break our problem into two conditions, which will imply the third, then we'll be happy in some sense. I'm being very vague there, but if you understand the spirit of it. So how we can do that is, instead of worrying about OA equal OB equal to OC, since we have this equality type condition, we can break it as OA is equal to OB and OB is equal to OC. Right? And if we are able to satisfy just these two conditions, well, if OA equal to OB and OB equal to OC, then of course OA equal to OC, right? Does that make sense? So that means we don't have to worry about all three concurrences. We can just say a perpendicular bisector of let O is equal to perpendicular bisector of AB intersects perpendicular bisector of BC. So what properties does O satisfy? This gives us that OA is equal to OB and OB equal to OC. Does that make sense? So we were able to break our three concurrences into just two conditions. And we know that if these two conditions happen simultaneously, then we are happy. Does that make sense? Very vaguely. Yeah. So the proof is simple. The proof is, take the perpendicular bisector of AB, take the perpendicular bisector of BC, They meet at some point, call it O. This point O satisfies the property that O is equal to OB because O is on the perpendicular bisector of AB. And it also satisfies the property that OB equal to OC because O is on the perpendicular bisector of BC. So OA equal to OB and OB equal to OC. So OA equal to OB, OC. And we are done. Does it make sense? Good. So can somebody try to use this kind of idea for the incenter? So what is the incenter? We again have a triangle A, B, C. Now the incenter is a point I such that angle bisectors of angle BAC and ABC, angle. No, sorry, what am I doing? Something angle is CBA, angle AC. Yeah. So these three angle bisectors converge at the point we call I. Okay, this point I is called the incenter, where these three angle bisectors come. So can somebody prove that I exists or these three angle bisectors come from?
So
Could I?
we take I.
Yeah.
If we take I to be the intersection of two of the perpendicular bisector of angle A and B.
Angle bisectors of A and B. Okay, so I is equal to angle bisector of angle A.
Yeah. So
Let me
then the
do.
distance.
Yeah.
The distance,
let me-
since it's on the angle bisector of A, the distance from AB and AC is the same. If we draw perpendiculars, then the distance from AB and BC is the same.
Yeah, this is what he's saying. So what she's saying is, if I have some point, any point on the angle bisector, there is another property that it satisfies. And this is a defining property of the angle bisector. Like earlier, the perpendicular bisector has this defining property that the distances to the sides were equal, distances to the vertices were equal. Now the defining property is that distance to the sides is equal. Okay, I'm sorry, I keep doing this. That these two lengths are equal. Yeah. So at I, we get to know that since it's on the angle bisector of B and C, we have this length is equal to this length, but also this length is equal to I. So we get that distance of I to AB is equal to distance of I to AC. And that would mean that I is on the angle bisector of angle A. Does that make sense?
in the circumcenter, means in the circumcenter we knew that the distances to the vertices were equal because this is a circle and that makes it a radius. But for
No,
incenter,
no, no,
how?
no, 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 no. So we don't have a circle A pair. What do we want to prove? We know that we have a triangle ABC. We want to show that there is a circle. We want to show that there is a point O such that OA is equal to OB equal to OC.
Okay, got it.
So what we said is take a point O such that it's on the perpendicular bisector of AB and the perpendicular bisector of AC, or like perpendicular bisector of BC. Like this is a construction that you might have seen in school when you do it with compass and ruler. You take two and intersect them, right? Once you
Yeah.
intersect them, this point will have the property that it's actually equidistant from all three, because we know that each of the pair gives us a condition, and those combine to all three things. Does that make sense?
Yes, makes sense. Okay.
I
For
have
the
a doubt.
incentive, just let me complete. I'll let you say after that. Is that okay? Yeah, so for the incentive, we have the same thing. We want to show that these three angles bisectors concur. So we find that there is a point such that it's if a point is on the angle bisector, it's actually equidistant from the two sides. That's the first thing we observe. That I'll let you prove. It follows using congruency. I'm not proving that right now for time reasons. But if you prove this, that angle bisect, if some point is on angle bisector of B, then that means it's equidistant from AB and BC. Similarly, if it's on angle bisector of C, then it's equidistant from AC and BC. And these conditions combine to say that it's I is on angle bisector of I is on angle bisector of angle A. So I is actually on all three angle bisectors. And sorry, please continue. I interrupted you.
Can you please go to the circumcenter diagram now?
Yes. Yeah.
Like, is it perpendicular bisectors or the perpendicular from the side?
Perpendicular from the side, which is from the midpoint, right? So how do you prove this? You say that there is an RHS congruency. Let's say this point is M1, or you can use Pythagorean theorem. So what is length of OB? OB is over OM1 square plus M1B square. And OA square is OM1 square plus M1A square. So if OA square equal OB square, then AM1 square equal M1B square.
My doubt is like, will M1, O, and C, it won't be a straight line, or will it be a straight line?
No, it won't be. It doesn't, like,
Okay.
you can imagine this, right? Like,
Yeah.
there is no need, like, I can place A to be any point on this circle and it has to be the same thing, right? But this does not change the center of the circle or the midpoint of BC.
Okay. Thank you so much.
Okay, good. So centroid, I'll let you prove. You can prove. And orthocenter again. Okay. Right. Orthocenter, there is a nice idea which does not involve using angle chasing, but there is also proof that you can do using angle chasing. I'll suggest you try to find both, and if you can't, you can always reach out to me. Okay. Then finally, the other element. Yes. The final elementary thing that I want to talk about is this thing on angles on circles. So you must have all seen this. Let's say these are let's call these points B and D. So if this is A1 and A2, and this point is C, then we know that angle BA1 D is equal to angle BA2 D. And these 4 points are concyclic if and only if this condition holds. So it goes both ways. And the other thing is angle BA1D is angle DCB fine. So can anybody tell me the proof of this statement? I assume a lot if you know this.
Yeah, so can I?
Yeah, please go ahead.
Yeah, like I learned this in school. If we join BO and OD, then we get just that, and we also join A1 OC, A1 to O,
Okay.
then we get two nice isosceles triangles,
Good.
and I guess that helps.
Yes,
Basic
very good.
angle.
Yes. So what they're hinting at is this proof that observe that OB is equal to OA, OA1, because these are on the circle. And similarly, OA1 is also equal to OD. So what you end up getting is this angle and this angle are equal because of the isosceles triangle, because OA equal to OB. Similarly, on the other side, this is probably not visible. Let me put a lighter. These two angles are also equal. Okay. So then we find that angle BOD is equal to 360 degree. Sorry, just is equal to angle OBA plus angle BAD plus angle D, no, AD. Yeah, this angle is just the sum. The angle here is the sum of the angle here. It's uh, so this angle is the sum of this angle plus this angle plus this angle. Does that make sense? So it is just BAD we just have plus OBA is equal to what? By our observation, OBA is equal to BA, sorry, A1, A1, A1. One, is equal to angle OBA is what? BAO, BA1 plus, and similarly BAD just BAD. I'll keep it to the side. Angle BAD. And A1DO is what? Again, we know A1DO is equal to OA1D. So these two angles again are just BA1, sorry, BA1D plus angle BA1D. Okay. Angle Does that make sense?
Yes.
Is the first equality true?
Which one?
The first
This
BOD
one.
one.
Okay, good. So what is BOD? This is 360 degree minus the reflex version of BOD. Yes.
Yes.
But 360 degree minus reflex angle BOD is what? 360 degrees is the sum of the angles of a quadrilateral, right?
Yes.
So this reflex angle BOD is just the sum of the other angles.
Okay. Thanks.
Like when you add reflex angle BOD to the other angles, you should get 360 degree.
Okay. Thanks.
Good. So this gives us that the angle at the center is twice the angle BA1D. But then it's also the twice the angle BA2D. Because what's the difference between A1 and A2 in this proof? Nothing. So that means that angle BA1D is equal to angle BA2. Does that make sense? Okay, good. Now you can prove the final thing, BA1D equal DCB plus DCB equal 180 degree in many ways. We'll just go with the simplest proof that twice BA1D is BOD. Twice angle DCB is equal to angle BOD plus reflex angle BOD is equal to 360. So angle BA1D plus angle DCB must be 180. Does that make sense?
Wait, I didn't follow the last line you wrote. What you did actually?
Yeah. So I said BA1D is the half of okay, BA1D is half of this angle. Yes. And BCD is half of this angle. Like the same type of argument.
Okay. Okay, got it.
So
Got it. Yes, got it.
their sum is the half of this angle. This angle is 360 degrees.
Got it.
Okay, good. So these are the angle chasing results that we typically use. Is everyone good with this? Perfect. So we are at a good pace. Okay. So coming to Simpson, what is this? So we have a circle and we have 4 points on it. Let's call them A, B, C, and P. Yeah. So from P, what I do is I drop perpendiculars on all three sides of the triangle ABC. So I drop a perpendicular here, I call it X, I drop a perpendicular here, I call it Y, I drop a perpendicular here, I call it Z. Okay. Simpson line states that X, Y, Z lie on a line. That these 3 points are collinear. Okay. So how can we prove such a statement? This feels very strange right off the bat. Okay. So what are the methods that you have learned in school to prove collinearity?
We can prove that angle PYZ and angle PYX both sum as 180 degrees to prove the
Good.
collinearity.
Prove that angle PYZ plus angle PYX is equal to 1. Let me not write it. Let me write it as So now the problem here is in some sense that XYZ are points which are relatively strange. Straight off the bat, you don't like one doesn't know immediately like how do we talk about these angles. A, B, C, P are on a circle, so it's relatively nice. So the question becomes, is there a way of finding angle PYZ in terms which are nicer? Does that make
We
sense?
can start by noting that ZA or YP is cyclic.
Good observation. Angle PZA is equal to angle PYA equal 90 degrees. Yes. So what does that mean? That if because these are on the opposite side, that their sum is 180 degrees. So E Z A Y. Okay, does that make sense? So PZAY is cyclic, and similarly, PYX is also for similar reasons, and for similar reasons we have PZXC. Yeah, no PZXPC. We get these three. Good. So
Yeah,
yeah.
I wanted to confirm that PYA is 90 or PYZ is 90.
PYZ is no PYA is 90, right? Because we dropped the perpendicular onto AC. Like XYZ are not existing before. However, they created, we dropped perpendiculars onto the three sides.
Okay, got it.
Good. So now that we have these cyclicities, how do we talk about angle PYZ from our previous discussion?
So we will have that PYZ will be just simply PAZ.
Good. Angle PYZ is just angle PAZ. And even I can, so I've eliminated Y from this angle, I can even eliminate Z from this angle. So this is just 180 degrees minus angle BAB. Yes. Good. That's great. So similarly, can we say anything about the other angle, which is X5P?
It will be 180 minus XCP, which is BCP.
Yeah.
No, like 180 minus BCP.
Sorry.
Like XCP is the same as BCP.
Okay. Good. So what do we want to prove now? Prove that angle PYZ plus angle XYP equal 180 degree. This is what we wanted to prove. But we have that PYZ is just 180 degrees minus BAP plus angle plus 180 degree minus angle BCP. Yeah. This is 360 degree minus sum of the angles BAP plus BC. How much is angle BAP plus BCP?
180 degrees.
Good. So this is just 360 degrees minus is equal to. That's it. Yeah.
Bhaiya, how is BAP plus BCP 180 degrees?
So BAP plus BCP is 180 because they're on a circle.
Oh, right.
Yeah. So here what did we do? The goal was simple. We made simple observations. Okay, we have these nice cyclicities. And what was the thing that we wanted to do? We wanted to prove we wanted to understand two of the angles. But they seemed relatively strange because the Y and Z were hard to handle. So what we just tried to do is just eliminate Y and Z and try to understand them in simpler terms. And because if you can simplify them enough, you just get the solution. Does it make sense? In a lot of easier problems, this will be enough. You just try to simplify and make simple observations and try to see what works. And just
Excuse me,
understand.
how is PYSC cyclic?
Okay, PYXC is good. So PYC is 90 and PXC is 90.
Yes, yeah.
So they are equal angles.
Got it.
There might be a configuration issue here, right? Because you put X between B and C, but there may be a case in which X is beyond C, right? In that case, also it still be cyclic, right? Because
yes, because
PYX plus PXC would be
yes, that's why it's important that these angles are 90 and not like some other pairs of angles, because then these configurational issues will pop up.
Okay.
Good.
I have a question.
Yes, please go on.
Can you please? Why is angle PYZ is equal to PAZ?
Yes. So we have this cycles PZAY because PYA equal PZA, right? And they're both 90, so their sum is 180.
Yeah.
So we have this cyclicity. Now, if we have this cyclicity, then PZ is just a chord in this circle.
Yeah.
So we'll have PYZ is equal to PAZ.
Thank you.
Sir, can I?
Yeah, please.
It may be somewhat neater to prove that angle PZY equal to angle PZX, because angle PZY is PAC and PZ PBC.
No, for sure. Like so, you can simplify this proof in many ways and different configurations. The goal was just like you can just pick any pair of angles that will imply the linearity and try to just understand them, and it will work. So as you said, you can pick any other pair and it will work. And some pairs will be cleaner than the others, but if I don't write it as these 180 degrees, so because these configurational issues are basically the thing, right? Where is P placed? How do I know that is outside? How do I know which is inside? So these are in place. So it's
one question.
Yeah.
How did we get angle PAZ is equal to 180 minus BAP?
Yes. So PAZ and okay, this one. So this is the angle we are talking about, and this is here. Like Z is just a point on AB. Z was the foot of perpendicular from P onto AB. So just by linear pair or what, I don't know what the correct term is. They're on a straight line, so the two angles will sum to 180 degrees. Does that make sense?
Yeah, thank you.
Good.
So the line which connects XYZ, you call this line the Simpson line.
Precisely. So this line is the Simpson line. Good. Does that make sense? Any more questions? Please feel free to ask. There's no.
Sir, I had a different idea.
Yeah, tell me.
Yeah, that angle AYZ is equals to angle XYC.
Yes, even that will work. So that's
And
what I
then
said,
90
right?
minus and 90 plus.
Yeah. Okay.
Yes.
Not exactly. Then you have to still prove some equality. But yes, so the point is you can try to prove any pair of angles and you'll have to shift them using these cyclicities onto something nice. And because they're on a circle, something is gone. This is the rough way this proof goes. Okay. Um, any further questions before I move on? All right, I'll move on. So the final thing is, if you remember earlier, what did we prove? That we proved from ABC, if we have a triangle ABC, we showed that there was a point I, which was on the angle bisectors of angle A, angle B, and angle C. And how did we prove that? We showed that this point I is actually equidistant from all three sides. Yeah. So we showed
Yes, yes.
this. Good. So this is what we showed, and the idea, the thing to observe is that this means that there is a circle with center I, which is tangent to all these three sides by just taking that length as the rate, that distance as the radius. This circle is called the incircle. Okay. And the points at which this circle touches the sides or the feet of the perpendiculars from I are called the in-touch points. So I'll just call them D, E, and F. Okay. So now the goal is simple. Just understand these lengths AE, AF, BF, BD, DC, and CE. Okay. The goal is to just understand these lengths. And how do we do that?
I wanted to ask that. So here, are we defining that when BA touches the circle, it touches only one point, or there is any definitive proof that it does not touch more than one?
I mean, so how do you prove? Have you proved that ever that the tangent, like you might have seen this proof, I don't know, that if you have a circle and a center, and if you have a tangent, that this angle is 90.
Yeah, I've saw this.
Yeah, so it's just you can try remembering that proof. It's I think it's in NCERT. It was at least when I was in school, which is not that long ago. So it should still be there. Anyway, the point is that since this is a perpendicular and this is the point closest, so if you have a circle, it cannot intersect at any other point because there is no point as close as this point to BC. Oh, okay. Anyway, so the point is just like D is the closest point to I. So if we just make the circle with center I and radius ID, there is no other point on BC that can touch it. Because that would mean that there is a point even closer. Does that make sense?
Yes.
Okay, good. So then you have this incircle, and you want to understand these lengths. So can somebody just tell me how we understand these lengths?
Can you repeat what you actually wanted to do?
We want to prove, we don't have anything to prove. We just want to find out what BD is what. What is BD? What is this length? In
BD is
terms of,
equal to BF is equal to S minus B.
how do you prove that? How do we find that?
Yes, so we know that BF is equal to BD.
Good. So let's prove that quickly.
Similarly,
Just a second. I agree with you. Let me just say this for the sake of many people. So we know that these two angles are equal, right? Because this was the angle bisector, right? And this angle is 90. This angle is 90. And this length is common, right? So by your RHS similarity thing. We can get that, or like whatever similarity you like. No, this is just ASA. What is it called?
It's a
Yeah, this is
congruence.
just yeah,
Is it?
ASA congruence. This is ASA congruence. You get that. Oh my god. This length is equal to this length, and this length is equal to this. Okay. Yeah. So please continue. We know that BF equal BD.
Similarly, DC is equal to DE.
Uh,
And
CD equals CD. Yes.
and AE is equal to AF.
And AE equal to AF. Good.
The sum of them all is equal to the perimeter of the triangle.
So let's call these X, Y, and Z. Then we know that like BF plus BD plus CD plus CE plus AE plus AF is equal to 2x plus 2y plus 2z. But this is also equal to the perimeter. Because this is just the sum of the three sides. So this is A plus B plus C. Yeah, continue.
So X plus Y plus Z is equal to perimeter by 2, which is
Z
equal to S.
perimeter by 2. And this perimeter by 2, we decide to call this the semi-perimeter. And this is this. We usually use S for this. Okay, go on.
And for example, BC, which is equal to A, is equal to BD plus DC, which means is equal to X plus Y. So if we subtracted from like, and B is similarly CE plus AE. So if we subtract S from B, we get X.
Perfect. So we have these X, Y, Z. Yeah. So we know X plus Y plus Z is half of the perimeter because 2X plus 2Y plus 2Z is at 2S. So now you can just see that, oh, X plus Y is just BC. So X plus Y is equal to A. So that means Z is equal to S minus X minus Y, S minus X. Yeah. Just to write this is AF equal to. Yeah. So this length is S minus A. This length becomes S minus B by the same argument. And this length becomes S minus C. Does that make sense? So this was to just demonstrate how we can like make basic observations and try to find different things. And this will be useful in a bit as well. Somewhat useful. Not very useful, somewhat useful. Hopefully. Anyway. Does this make sense to everyone?
Yes, Priya.
Okay. Great. So I think this is the last we talk on the normal stuff. So I have all right. Okay. So the rest of the session will be a little harder than what we have done till now. And it will be a little more fast paced because I want to do something for like people who have seen these things before as well. So I'll talk about plane transforms. So anybody who feels like it's already been a lot and this is a lot to process, you're like feel free to leave or like whatever. So what I'll now do is over the next 15 to 20 minutes, I'll go over some plane transforms and those kinds of things. Okay, it's actually already 3, so I should conclude. Okay, so let me do this. The session has basically concluded. I think we can even stop recording. But for some people who are curious, I'll just talk a bit about plane transforms just because I feel like I've not given something for many people. So just something for everyone. So I'll talk a bit about plane transforms and then overall conclude and just stick around for 10 more minutes in case people want to chat or have any questions. Like
So should
about
I stop it?
Yeah, unless people have comments or questions. Okay, fine. All right, you can stop recording.
Okay.